Hello everyone, and welcome back to our channel. Today, we have an exciting topic to discuss. The solid principles. Whether you're a beginner or an experienced developer, understanding and applying these principles can greatly improve the design and maintainability of your code. So, let's dive right in. The solid principles are a set of 5 principles that help us design software that is modular, flexible, and easy to maintain. They were introduced by Robert C. Martin, also known as Uncle Bob, and have become fundamental concepts in object-oriented programming. The first principle is the Single Responsibility Principle, or SRP. It states that a class should have only one reason to change. In other words, a class should have a single responsibility or job. By adhering to this principle, we ensure that our classes are focused and have a clear purpose, making them easier to understand and maintain. Let's consider a practical example. Imagine we have a class called User that handles both user authentication and user data management. According to the SRP, we should split this class into 2 separate classes, one for authentication and another for data management. This way, if there are changes related to authentication, it won't affect the data management part, and vice versa. The second principle is the Open-Closed Principle, or OCP. It states that software entities, classes, modules, functions, etc., should be open for extension but closed for modification. In simpler terms, we should strive to write code that can be easily extended without modifying the existing codebase. Imagine we have a class called Shape with a method called CalculateArea. According to the OCP, if we want to add a new shape, like a triangle, we should be able to create a new class for the triangle without modifying the shape class. This way, the existing code remains untouched, and we can extend the functionality without introducing potential bugs. The third principle is the Liskov Substitution Principle, or LSP. It states that objects of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. In other words, a subclass should be able to substitute its superclass without breaking anything. Consider a classic example with shapes again. If we have a method that expects a shape object, according to the LSP, we should be able to pass any subclass of shape, like a rectangle or a circle, without causing any issues. This principle ensures that our code is flexible and doesn't rely on specific implementations. The fourth principle is the Interface Segregation Principle, or ISP. It states that clients should not be forced to depend on interfaces they do not use. In simpler terms, we should create smaller and more specific interfaces rather than large and general-purpose ones. Let's say we have an interface called Printer with methods like print and scan. If a class only needs to print but not scan, it shouldn't be forced to implement the scan method. By adhering to the ISP, we can break down large interfaces into smaller ones, making our code more maintainable and reducing unnecessary dependencies. Last but not least, we have the Dependency Inversion Principle, or DIP. It states that high-level modules should not depend on low-level modules, both should depend on abstractions. Additionally, abstractions should not depend on details, details should depend on abstractions. Let's say we have a notification service class that sends notifications. Instead of directly depending on specific notification providers, we should depend on an abstraction, like an iNotification provider interface. This way, we can easily swap different providers without modifying the high-level module, promoting flexibility and scalability. And that's a wrap. We've covered the 5 solid principles: SRP, OCP, LSP, ISP, and DIP. By applying these principles in your code, you can improve its maintainability, flexibility, and overall design quality. Remember, these principles are not strict rules, but rather guidelines to help you write cleaner and more maintainable code. Experiment with them, practice them, and see how they can benefit your projects. Thank you for watching. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell to stay updated with our latest content. Until next time, happy coding!